Hello coders! In this video, we will solve next question from our LeetCode 75 list. And let me take you to the screen first. 1 minute. And yeah, here, this is the question. Which is smallest number in infinite set? Okay. The question says that you have a set which contains all positive integers 1 to infinite. Okay. Implement the smallest infinite class where smallest infinite set initializes smallest infinite set object to contain all positive integers. Okay, then what? In popSmallest will remove and return the smallest integer containing in the infinite set. So basically we have this set that 1 to infinite, and when we call first time popSmallest, then it will remove 1. Then we call the next time popSmallest, it will remove 2 because we removed 1 from the set, so it do not have now, and then we remove 2. Likewise it will continue. Okay, then what we have void addBack function adds a positive integer num back in infinite set. Okay, so it basically saying ki we and what it says, if it's not already infinite set, if it is not in a infinite set basically. So basically what is saying ki, let's say we call popSmallest function first time, we pop out 1. Now we have 2 3 4 5 6 7 up to infinite, and addBack function adding number 2. So we already have 2, right? Or anything like which is greater than or equal to 2, that addBack function is adding, but we already have those all numbers in our set, so we will not add that in the set. But if it is adding 1, then we need to add it, because we just removed that 1 and we were starting from the 2, like we have the numbers from 2 to infinite, and it is adding 1, so we need to add it. So basically it's like that. So yeah, so that was the question, and let's take an example like how we can solve it. So my first intuition, like string in my mind, like what my approach is, just take a set which is ordered set, and I take a number which start with 1, and we will say ki when the popSmallest will function will get called, I will check ki my num variable is at what number, and check the set as it is ordered set, check its first element, the first smallest element is what, and the num, and whichever the smaller, return that and remove that. Basically if it is num is smaller, then do num plus plus, and if it is from the set, then it is the first element and return that the first element basically. And while adding back, add just to the set. That's my approach. So let's write that in code. So what I want key, I will say key I have a set, ordered set. Basically set means ordered set, and if I write it unordered set, so that will be explicitly unordered set. Okay, and what I want to say here, yeah, it's unordered set, so let's take set int, and I will say it is set est. Okay, I will initialize it with nothing, like empty set popSmallest. So positive integer set, I'm saying that is starting from num. So basically num, when the smallest infinite set will get called, I will start it with 1, and now the num is basically for basically infinite numbers for me. Okay, so when the popSmallest will get called, what I will say, check key if my num, okay, first I will check if st is empty or not. If st dot empty, if it is empty, then I need to return num and need to do plus plus. So I will say return num and do plus plus, like just go to the next number. If it is 1, then go to the 2. If it is 2, then go to the 3. Likewise, if st is empty. If st isn't empty, then what I will do, I will check. Let's take I will take iterator is equal to st dot begin, or I can just from here itself take star st dot begin. So, and I will say ki if id is less than num, then return the id or return num. return num plus plus. So when I will return it, so before that what I will do, I have to erase the uh, begin, right? Sets begin. So for before that I will say that return result basically it is id, and I have to erase st.begin. So I will say erase st.begin or star st.begin, and yeah, we need to uh, erase that iterator. So st.begin, I think we'll try. Okay, add back. What I need to add back, I need to add back the num. Okay, so I will just add it to the set, because set will store unique numbers, and if though I will add more than nums, like before that I will what I will check. Okay, the num becomes okay, my this num I will take. This num is already less than this num, or less than or equal to this num, then we don't need to add this number because we already have it in our set. So just return from here. Otherwise, so my num is basically less than this num. Basically our infinite sets starting point is way ahead or ahead from that num. So I will add it to my set st.insert num. Okay, that's it. So just run it. I'm just worried about this thing. Net is also slow. And okay, yeah, as expected, it should be star because we are erasing iterator. Just run it. It's not. That's also erase st.erase st.begin st.erase st.begin. Okay, this was if function. So net. Okay, let's just submit it. Yeah, it is accepted. And yeah, what the time complexity for this, like we are storing in set, so it will take whatever the n, that is log n complexity, to find that number if it is present in that or not. But we are not doing that, right? We are just erasing it. So yeah, it will take big of one time to erase the first element, but it is set, so it will take log n time. And yeah, so max time it is taking is log n, basically log n basically n means the numbers in that set, the size of that set basically. So yeah, this is the time complexity, and space complexity is big of n, that is the size of set that we are storing. Yeah, big of n, and that's it. So yeah, this was the today's question. If you understand it, and then like, share and subscribe, and we'll meet in next video. Till then, bye.